Good evening, friends. This is Manish Khandelwal. I am a mechanical engineer, and the details of my experience are mentioned at the bottom of this slide. As I communicate every time, I am running two channels on YouTube. One is Factory Forward TV, where I post presentations on technical matters. The other channel is Brainy Builders, where I post presentations on mathematics and science subjects suitable for students studying in class 6 to 8. Today's topic, value stream mapping, is an extremely important tool to find out the activities which are not contributing to the value of the product or which are contributing to the inefficiency in a process. Value stream mapping therefore is used for all the industries going for lean manufacturing. I have tried to make value stream mapping understand better by giving an example in today's presentation. I would like to take another example in part 2. This is part 1. So I will be taking another example in part 2 of value stream mapping to make this activity understood better. Friends, we can divide the activities in a manufacturing sectors in two categories: value added activities and non-value added activities. The value added activities are those which are contributing to the value of a product. These are the activities for which the customer pays us. For example, machining of a product or press operation, welding, heat treatment, painting, etc. Here the shape of the material also changes. The non-value added activities are those which are not adding value to a product. And these are the activities for which the customer doesn't pay us. These non-value added activities can be divided into two. One are essential non-value added activities. For example, quality inspection or documentation, etc. These are essential, but the customer is not paying us for this. Then the second type of non-value added activities are wasteful activities like waiting for the material, additional transport of the material, overproduction, inventory, etc. In an extremely simple way, the complete activities in a manufacturing sector can be broken into three parts. One is receipt of material, second is processing the received material, and third is supplying product to the customer. There surely would be many interconnected and interrelated activities to perform these three activities. While doing it, there are possibility of wastages getting generated. The purpose of VSM or value stream mapping is to identify these wastages so that these can be addressed and reduced or eliminated to get better efficiency. The wastages in a manufacturing sector can be placed in 7 categories. These are popularly known as TIM wood. T is transport, I inventory, M for motion, W waiting. There are two O's, one is over process, second is overproduction, and lastly D, defect. I have already covered these 7 defects in details in one of my previous presentations. Just a brief here. The movement of a material in the shop floor comes under this category, transportation. Then the material in the form of raw material or work in process or finished goods, which remains not supplied to customer, comes under the category of inventory. Movement made by operator is also a waste, and this is known as motion waste. Then the operator waiting for the instructions to move forward, or it is held by quality for some reason. that is the waiting loss. Then any process for which the customer doesn't pay us, we are doing something extra, that is over process. Then we have overproduction done, and defect, of course, this is the complete scrap or waste. So these are these 7 wastages which may occur while we are performing these 3 activities. As I said before also, the purpose of the value stream mapping is to find out the wastages, identify these wastages so that the team can analyze these wastages using the quality tools and try to reduce and eliminate to get better efficiency. Let us take one example here, friends. The working hours in a company is 8 hours 50 minutes per day, and they work 5 days a week. Lunch is for 30 minutes. There are 2 tea breaks of 10 minutes each. That means total 50 minutes break out of 8 hours 50 minutes. So that means 8 hours net working for 5 days. So 8 into 5, 40 hours per week is the working hour. This is the process. The PPC of the company is receiving the customer schedule. They are giving a monthly plan which says 950 pieces per day have to be supplied. The PPC breaks the monthly plan into daily plan and gives to all the processes, there are 3 processes, then packing and dispatch. The materials supplied by the supplier are coming into the process 1. So this is a very rough process flow for the customer order. Now we collect the data to make the value stream mapping. The data shall be of 3, it can be divided into 3 parts. One, of course, is inventory. Second is downtime, and third is changeover time. We shall take these time into the seconds only. The figures I have taken here are just imaginary. The actual figures have to be put. So the monthly data is divided into 4 weeks. Starting week, we take the raw material inventory. How many days inventory we have. So we write it here. Then beginning of the week, we write the production of the previous week. And we find that the average weekly production was 10,450. The average raw material inventory was 5.15 days. The downtime, weekly downtime is noted, and then we take the average. To find out the uptime, we just have to, this was 8 into 5, 40 hours. That means 1,44,000 seconds. So in 1,44,000 seconds, we reduce the downtime, 4723. Then 1,44,000 minus 4723 divided by 1,44,000 shall be the uptime. I have taken changeovers separately here. 1, 2, 3, 4, 4 changeover, 4 timings have been taken. The average is 1470. Many companies reduce 1470 also from the main time, from the up, so that uptime will reduce. Many companies does it, many companies do not do it. There is only one operator in one process, and the cycle time for process 1 is 45 seconds. So I have taken data only for process 1. Remaining process data is also available here, but I have just not highlighted it. I just explained in process 1. Same way it has to be done for process 2, process 3, packing and dispatch. Now let us make the value stream mapping. Value stream mapping is done in 3 phases. The first phase is information flow, where a customer is giving schedule to the company. So if the customer is giving schedule electronically, then this symbol will come, and the daily requirement is 950 pieces. This is hypothetical again, and the customer has given the requirement to the company, PPC. Now PPC will give this information to purchase or directly to supplier for supplying the material. They give the weekly plan to them. If it is electronically, then this symbol will come, otherwise straight arrow will come if it is done telephonically. PPC will also inform all the process for the requirement. This is process 1, process 2, process 3, then packing and dispatch. This is the information flow. Next is the material flow, where first the material is coming from the supplier. This will come for process number 1 first. This is process 1. Now be careful here. This is the average weekly inventory 10450. When we are calculating the average inventory days, we shall be dividing the weekly average inventory by the daily requirement. So if we divide 10450 by 950, we will get around 11. Many people convert this 10450 into the daily inventory. They divide it by 5. That is wrong. So this has to be weekly average, and it has to be divided by the daily requirement. So it comes 11. The operator, there is only one operator for this. Changeover time is 1470 seconds. Cycle time was 45 seconds. One more important thing, the process time is 93 seconds. So process time is basically from start to end for the product. This include value added and non-value added activities both. So cycle time is value added. So in this, the non-value added activities are 48 seconds. Downtime was 4723 seconds, and uptime was 96.72%. So I have done it only for process 1. The same calculation will be applicable for remaining processes. This triangle is the symbol for inventory days. This is a symbol when we are moving to the next process. So same way, the calculations for process 2, 3 shall be done, and then packing and dispatch it shall be done. And finally, we supply the finished product to the customer. So here, of course, our material flow will get complete. This is receipt of material, process of the material, supply of the material. Last phase is the lead time flow, where we summarize the activities. We make this ladder where on the top, these are the non-value added activities. Here, of course, we are writing only about the inventory days. So this is the raw material inventory days. Basically, if you recall, it was raw material inventory days. From here, these inventory days will come. Cycle time, this is the only value added activity, 45 seconds. For other non-value added activities, we can make one more ladder. But here, of course, I am making only for inventory and the cycle time. You can see the average inventory 11 is coming here. Then next process is 38 seconds cycle time. This is coming here. Then average inventory 7.37. It is coming here. So we make this ladder where in the top side we have the cycle time. That is the only value added time. On the top side, it is the production lead time. This is the inventory. So you can see the production lead time is 36.5 days against the value added time of 158 seconds only. So we have a lot of scope to improve here, reduce this inventory, one, and secondly we need to find out the gap here, why this gap is coming, how to reduce this gap. Friends, after VSM is made, then we know the inventory days, we know the difference between the process time and cycle time. So these are the two things which we have to address. We need to use the QC tool to address these things. Videography actually is the very popular method and very effective method to capture the inefficiencies and wastages. So once we are done with this, we make some changes, then it is required to make VSM again and check it, then again see the areas of improvement and again do the VSM. So this is a continuous process. So thanks friends, this was all in part 1 of value stream mapping. I shall be back quickly with part 2 of value stream mapping. Hope you have liked it. Those who have not subscribed my channel, they can do so to get the access to my presentation fast. Thank you.